algorithm. So first you see the procedure, how to suppose one linear programming problem is given, then how to solve it by dual simplex method or dual simplex algorithm. Okay, so using dual, this is different, but using dual simplex algorithm or dual simplex method, then this is the different one. Okay, now I am audible.
Yes, sir.
Okay. So
Yes, sir.
first you see the theory portion. Okay, so see the theory portion. So the dual simplex algorithm to solve an linear programming problems consists of the following steps. So steps are, first step is what? Convert the problem into minimization problem if it is initially in the maximization form. So always we convert it into the convert it convert it into the maximization, means if minimization problem is given, so always we convert it into the maximization. Okay, so next one is what? Another one is convert, step 2, convert greater than or equal to symbol type constraint into less than or equal to type by multiplying both sides of consist of by -1. Okay, so next one is what? If greater than equal to symbol is present in, then we convert it into the less than symbol by multiplying both sides by -1. And next number step 3 will be convert the inequality constraint into equalities by adding of slack variable and obtain the initial solution and express the above information in the form of table known as the dual simplex method. Next step is what? We know when less than or equal to symbol is present in the constraint, then for making equality, we add slack variable. So first step is what? First step is if minimization problem is given, in case of dual simplex algorithm, we convert it into the maximization. Okay. If maximization problem is given, then okay, no problem. Okay. If minimization is given, then we convert it into the maximization. Second step is what? All constant size should be less than or equal to. If greater than or equal to sign is present, then we convert it into less than or equal to by multiplying both sides by -1. Okay. So this is the second step. Third step is what? Next we convert this inequality into equalities, means what? Less than or equal to symbol present. So how to make it equality? Using slack or surplus. Slack variable obviously we know. So here we add what? Slack variable. Okay, then we get the dual simplex method. Okay. Next step 4, this is the important one. Compute Cj minus Zj for every column. Means what? Next we calculate delta J value. This is just Cj minus Zj is same as delta J. Delta J equal to what? Cj minus Cb into Y1. So Cb into Yj we write here Zj. So next one will be Cj minus Zj for every column. So here Zj means what? Cb into Yj is denoted by Zj, means compute Cj minus Zj means this is delta J value. Okay. So Cj minus Zj for every column. So here there are 3 possibilities. So what are the possibilities? So first one is if all Cj minus delta J, Cj minus delta J means Zj, Zj means delta J. You remember this is delta J. So if all Cj minus Zj are either negative or 0 and all Bi are non-negative, so this is important one, all Bi, small bi. Small bi means xb column is called small bi. If all bi are non-negative, then the solution obtained above is the optimal basic feasible solution. Means what? If our all delta j value, okay, here Cj minus Zj, but we read this is delta j. This is Cj minus Zj are either negative or zero, and all Bi means XB column. All XB values are non-negative. Okay, this may be zero or positive. Means should be non-negative. The solution obtained above is the optimal basic feasible solution. Then we call this case as the optimal basic feasible solution. Number two case will be if Cj minus Zj means our delta j value are either negative or zero, and at least one bi is negative. Means our, you see in xb column, if any one value is negative value, then we proceed to step 5. So step 5 we did later on. Next, step C, another case may arise. If any Cj minus Zj is positive, the method fails. So this is one of the important one. When dual simplex algorithm fails, if delta j, any value of delta j is positive, then we cannot apply dual simplex algorithm. So third number C is important. Okay, so there are three possibilities. When we call this gives us an optimal solution. If Cj minus Zj are either negative or zero, and all bi are non-negative, then this gives us an optimal solution. If all Cj minus Zj are either negative or zero, and at least one bi is negative, then we proceed to step 5. Step 5 we shall see. And next, if Cj minus Zj is positive, then this method fails. So up to step number 4 clear, everyone?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. So next you see what step number 5 is what? Select the row that contains the most negative bi. Okay, means what? If you see step number 4b point, if Cj minus Zj are either negative or zero, and at least one bi is negative, then proceed to step 5. So step 5 means what? Select the row that contains most negative bi. Means what? Sometime in xb column, more than one value is negative value. Okay, then we choose which element. Here most negative. Suppose -4 -5. First row element is -4, second row element is -5. Then we consider what? Most negative is -5. So -5 we select. So this row is called the key row or pivot row. Here you see how to select the key row or pivot row. This is depends upon select the row that contains most negative bi. In dual simplex algorithm, you see, we need not find out the minimum ratio. Okay, without finding the minimum ratio, by this step, we can find out the minimum, means what? Key row or pivot row. Okay, then we select the pivot row. The corresponding basic variable leaves the basis. This is called feasibility condition. Okay. Next, step 6 is what? Look at the elements of key row. Next, you see which row is our key row, and you see all the elements of key row. Number A is, second page, number A is, if all elements are negative, if all elements are negative, the problem does not have a feasible solution. Okay, if all the elements of key row is negative, then
Sir, it's non-negative.
Not negative, non-negative, sorry, non-negative. If all elements are non-negative, the problem does not have a feasible solution. Okay, so non-negative, then we cannot get a solution. Okay, next one is, if at least one element is negative, find the ratio of the corresponding element of Cj minus Zj, means delta J, row to these elements. Next, we find out if at least one element is negative, then we find out the ratio of this, means what? Delta J, this delta J element of this corresponding element, and this negative element of key row. Okay. Ignore the ratio associated with positive or zero elements of the key row. Means in key row, you search which elements are positive and zero. You ignore this. We will not find out these ratios. Only find out the ratio which is associated with negative sign. Okay. Choose the smallest of these these ratios. Okay. Smallest ratio from here we find out. The corresponding column is the key column, and associated variable is entering the associated variable is the entering variable. This is called dual optimality condition. Mark the key element or pivot element. So same as we mark this is pivot element or key element. And step number 7 is what? Make the key element unity, same as earlier process, and perform the row operation as the regular simplex method and repeat iteration. Means same as our simplex method, means old element, new element equal to old element minus intersection of key row, key column divided by pivot element. So this is the step. Okay, so then when you solve the problem, this one will be easy for you, because with the help of this theory, we solve how to solve the linear programming problem by dual simplex method. Okay, so up to clear this. Here 1-2 line you find difficulty there, but here what happen next? When you solve the problem, then you will see this will easily you can solve this one. So first you see the problem, and first one you see, next page you see, use the dual simplex method to solve the LPP programming problem. Maximize z equal to minus 3x1 minus twice x2. Subject to the constraints x1 plus x2 greater than or equal to 1, x1 plus x2 less than or equal to 7, x1 plus twice x2 greater than or equal to 10, x2 less than or equal to 3, and x1 comma x2 greater than or equal to 0. So first step is what? First you check whether our objective function is maximization or minimization. Okay, if maximization, then no problem. If minimization, then we convert it into the maximization. So first you see our given supplied problem is maximization, so we will not change, this remains same. Next condition, step number 2 is what? All constraint inequality symbol should be less than or equal to. All constraint inequality should be less than or equal to. So this should be less than or equal to means what? Here first constraint contains greater than or equal to symbol, means x1 plus x2 greater than or equal to 1. So immediately we convert this inequality into less than or equal to by what? Multiplying both sides by minus 1. So you multiply both sides by minus 1 in the first inequation, then you will get minus x1 minus x2 less than or equal to minus 1. Okay. Second constraint is inequality is less than or equal to already present, so no problem. Second will remain same. Third one is again greater than or equal to symbol present. So the third inequality, we convert it into the less than or equal to symbol by multiplying both sides -1. So minus x1 minus twice x2 less than or equal to -10. And the next one is x2 less than or equal to 3. So this remains same, no changes. Okay. So step number 3 is what happened. In step number 3, here all inequalities, constant inequalities are less than or equal to. Next, what we do, we make it into the what? Equality symbol. So all are less than, so we introduce here slack variable. Okay. For the first constraint, we use the slack variable plus s1. For the second constraint, we use slack variable plus s2. And fourth equation, we use plus s4. Okay. So here, similarly in the objective function, here slack variable is used. So similarly, we write here 0 into s1 plus 0 into s2 plus 0 into s3 plus 0 into s4 in the objective function. Means maximize z equal to minus 3x1 minus twice x2 plus 0 into s1 plus 0 into s2 plus 0 into s3 plus 0 into s4. So these are the select variables. So you see here x1, x2, s1, s2, s3, s4 all are non-negative, means greater than or equal to 0. Okay. So from next we make the table. So here you see how many equation? 1, 2, 3, 4 equation. How many variable? 6 variable. So we consider how many variable is equal to 0? 6 variable, 4 equation. So generally we cannot solve. So how many variable is equal to 0? Arbas?
Two variables.
Yes, two variable we consider 0. Okay, so if two variable is equal to 0, next question is same as earlier. Which two variable is equal to 0? So this is depends upon what? This is depends upon, you see, for which variable we get the identity matrix. So S1, S2, S3, S4 gives us the identity matrix of order 4. So remaining x1 and x2 equal to, we consider 0. So if x1, x2 equal to 0, if we consider, then s1 equal to -1, s2 equal to 7, s3 equal to 10, -10, s4 equal to 3. Okay. So next you make the table. So what will be the table? So same as earlier, B, then CB, next one is XB. XB means small bi here. Okay. Then we write this is x1. X1 means all the coefficient of x1. We have not changed here y1. Anyone, if you interest to write one y1, then you can write capital y1. So here x1. Next one is x2, s1, s2, s3, and Cj means coefficient of the objective function. So -3, -2, then 0, 0, 0, 0. Okay. Next you fill up this table. So fill up, how to fill up? Here, first you write, see the x1 column. You fill up x1 column, x2 column, s1, s2 column, s3 column, s4 column. Okay. So next here, identity matrix, first column of the identity matrix is S1. So in basic variable, in capital B column, we write S1 first. Second identity matrix column is S2. So S2. Third one is S3. So write S3. Next one is S4. Next CB. CB means coefficient of the coefficient of this variable means s1 coefficient is 0 in the objective function, s2 coefficient is 0, s3 coefficient is 0, s4 coefficient is 0. Okay, and xb is the current basic solution. So xb will be s1 value is -1, s2 is 7 already calculate, s3 is -10, s4 is 3. Okay. Next, you find out delta j value. Delta j equal to cj minus zj here written. Okay. And z equal to same as earlier, cb into xb. So 0 into -1 plus 0 into 7 plus 0 into -10 plus 0 into 3. So this gives us 0. And delta j value same as earlier we calculate cj minus cb into yj. So after calculating, you see delta j value is -3 -2 0 0 0 0. Okay. Then you see all delta j values are what? Either 0 or negative. And when we get the solution, all xb should be non-negative. So here you see -1 and -10 is present, negative value present in the xb column. All bi should be positive. So here bi are negative. Then this cannot give us the optimal solution. Then what we do next, we find out the here how to find out the key row and key column. So key row how to find out? In xb column, here most negative value is what? In xb column, Ishita, in xb, Roshni, key column, key row, how to search?
Sir, -10 is
Most negative,
most negative.
yes, -10. Here -10 is most negative. Means here -1 and -10. For these two element for these two element we cannot get the solution. So here -1 this is negative value, -10 this is also negative value. So which row our key row? Most negative. So -10 is most negative. So -10 means S3 row is our key row. We mark it key row. Okay. Next, we find out the ratio of delta J and corresponding element of key row, and restriction is what? The key row element, we consider those elements which are negative value, not 0 or positive. So, how to find out the ratio of key row? You see, ratio of this one means key column, how to find out? You see key column here, first one is -1, so -1 and -3. So we find out what? Delta J means delta J by corresponding element of key row. So -3 by -1. Okay, so value is 3. Then -2 by -2. -2 means first one, numerator will be delta J. Denominator is corresponding element of key row. So -2 by -2 is 1. Next, 0, 0 and 1 we will not consider. Why we will not consider? Because in key row element we consider those elements which are negative or which are negative. Otherwise we will not find out the minimum ratio. So 3 and 1, which one is minimum? 1 is minimum. Because -3 by -1 is 3, -2 by -2 is 1. So 1 is less. So this gives us for which column? This is for the x2 column. So x2 column is our key column, means incoming vector. So you see, first step is clear or not? In mathematically, I have written key row within bracket variable to lead the basis is minimum xbi means xbi such that xbi is negative, means we consider minimum value of those value of xy which is the minimum. So -1 -10, so -10 is minimum, so this is our key row. Similarly, key column, how to find out minimum value of Cj minus Zj, ratio of Cj minus Zj and Yrj, and Yrj consider those values which are negative. Zero or positive will not consider. Yrj means what? Yrj is denote the row, key row element. So here you see -3 by -1, -2 by -2. So minimum is 3 comma 1. So 1 is minimum. So 1 we get for which ratio? For this lies in the x2 column. So x2 column is our what? Incoming vector. And S3 column is our outgoing vector. So in the next step, S3 will be out and this is replaced by X2. So you say up to first table, this is clear or not? Anybody have any doubt? Binoy, Vishwajit,
No, sir. Sir, Kiro, can you please explain again?
which one? Key row. Acha. Key row, how to find out? Acha. When we get an optimal solution in the dual simplex method, all delta j value is less than or equal to 0, means either negative or 0, and all bi should be non-negative. All bi means xb column should be non-negative. This may be 0, no problem. Non-negative value means there cannot be a negative one. So here you see in this problem, first table is what? In the first table, this is delta j value is negative or 0. So we apply simplex method. If delta j, any one value of delta j is positive, then this method fails. So we can apply. Then how to find out the key row from xb column? From xb column, you find out the which one is the most negative. Xb column, you take the negative value. -1 is the negative value, -10 is another negative value. For these two, we cannot get the solution. So we take these two, -1 and -10. So -1 and -10, which is the most negative? -10 is the most negative. Okay, so -10 is the most negative. So -10 present in which row? So S3 row will be the key row. So you see this is clear or not?
Sir, for the key column, there was like a -1 and 1. So like, so we chose which one was the positive one, right? So like, since we chose the x2 row, I mean x2 column, which is like 1. So like, yes, right.
Again, you
So I said like when we like selected the key column, we calculated
hmm.
the ratio as 1 and -1, and we chose the x2 because the ratio was 1.
Or ratio, no problem. Here you see, oh, -3 by -1. Okay, but we take negative value -3 by -1. Okay, so this is 3. Then -2 by -2, 1. So which one is the minimum? For which ratio?
Yes, sir, I get it. So like 1 is minimum, then like 3. So that's why we chose that. And like what happens
Uh, yes.
if like
So this is
so like for
S3 means
if they're like
X2
same.
column is our key column.
So what if the like both of the ratios are same? Then what we do?
Well, both are so if they are both are ratio same, there is no rule now. So you choose any one. Okay, this is iterative
Okay.
method. So So first one, maybe if you consider, suppose both are same, suppose in x2 column and s1 column both are same, you can choose either s1 or x2. Okay, so if anyone choose x2, after 3 iteration get the solution. Anyone choose s1, then you will get after 4th iteration maybe this fellow. So there is no there is if tie up, then there is no rule for this one. We choose the which one is first we choose. Same as degenerate means what? If minimum ratio is tie up, then there is what? There is a problem. We find out how to find out the minimum ratio. But here there is no case. You choose anyone. Arbitrarily you can choose anyone. So up
Yes,
to
sir.
first table clear?
Yes, sir.
So
Yes, sir.
okay. So in the second table you see here the same as S3 will be out and this is replaced by X1. Okay. Here which one? Yes. S3 is out replaced by X2. Same as earlier method X2. So S1, S2, X2, S4. And here same as what we do, divided by -2, then we get what? This x to 5, 1 by 2, 1, 0, 0. So same as earlier process you apply and you will get the new table, second table. Okay. After the second table, you see same process you will apply. Same process. Second table to third table, same process you apply. Here from second table, can we say that we get an optimal solution from second table? Anybody? From second table, can we say that?
No, sir, because we have delta J value which is less than, uh, which is less than 0. So like negative delta J values are there.
Mhm. Not delta J, BI,
It is optimal, but
XB column. Oh, Nihal, yes.
sir, it is an optimal but not feasible.
So this does not give us an optimal solution. Why from the second table? Because you see in the second table, XB column you see, XB column is 4, 2, 5, -2. So here one negative value is present. So this does not give us a what? Optimal solution. So for -2 we get a problem. So here only one negative value, so -2. So our S4 is our key row. Okay, then how to find out this one? Key column. Here you see in key row, negative element is what? Negative value is what? Only -1 by 2. So you find out the ratio of -2 by -1 by 2. So this is only 1. So this is our incoming vector. Okay, so incoming vector is x1. So s4 will be out and replaced by x1. Okay, so in the same process you apply, same as find out the new element, you apply, then you see in the third table, delta J value is all are 0 or less than or equal to, and all XB column is positive. All element of XB column is positive. Here 6, 0, 3, 4, non-negative. Okay, so in the next page you see, therefore all Cj minus Zj less than or equal to 0, as well as solution value are also positive, means XB is positive. Hence, optimal feasible solution of the given linear programming problem is x1. So our x1 is 4, x2 is 3, and makes z equal to -18. So we'll try to solve this one. First you read the procedure, then you will try to solve. And this method is same. A new element, how to make the new table. New element equal to old element minus intersection of key row and key column. Here only difference is what? In dual simplex algorithm, no need to find out the what? No need to find out the minimum ratio. Okay, minimum ratio will not, without finding this, we can find out the key row. Clear this one?
Yes, sir.
Yes, sir.
Okay. Okay. So response to your name.